Okay, so we're ready for the third part, which is I can represent a relation with a graph and identify the domain and range. And then I can also determine if the relation is a function. So let's get started on that one. Okay, so here are some graphs that we're going to be given, and we're going to be finding again the domain and range. Now I want to do just a quick reminder for you. So the domain is your x values. Your range is your y values. Okay, now when you have a graph like the ones that are given here, these are called continuous. I'm not spelling that. C-O-N-T-I-N-O-U-S. Now, a continuous graph is a little bit misleading because most kids think that a continuous graph has arrows on the end, meaning it's continuous, which is true. But in terms of looking at the graphs here and functions, what we mean by a continuous graph is that all the points are connected together. Okay? In other words, by definition, it says between any 2 points, there's going to be another point. That's what a continuous graph is. Between any 2 points, there is going to be another point. But basically, when you're looking at it, it's going to be a continuous graph is a solid line. Okay? Then we're going to have what's called a discrete graph, which is going to be just points. Okay? It's not connected. Okay? So please note those two words down in your vocabulary. So under your vocabulary, we have continuous graph. Please check to see if that word continuous is spelled right, because it doesn't look right. Continuous graph, it's going to be a solid line. These are all three continuous graphs. A discrete graph is just going to be points. And I'll give you an example of that here in just a little bit on there, where I might or have already put it on here at the beginning. So when we go to find the domain and the range for these continuous graphs, okay, the easiest thing, I saw this trick once and I thought, when I seen it, I was like, that's how I need to do it, because kids are always having trouble with it. So what I'm going to tell you to do is box the graph. Okay, so in other words, here's my graph and I'm going to just draw a box around it. Mine is not perfect by any means, but hopefully you can see what I'm doing. Just box your graph. Okay, and when you box your graphs, then your x values, if you'll think about it, this right here is our interval notation we were doing earlier with absolute values. See how that is? There's your endpoint, and so we're going to say that your domain, your x, is less than or equal to, what number is that? 3, but greater than or equal to, and I do equal to in this case because this is considered solid because there's a line there. You don't see any open dots, and a -5. Okay, so think of that like your interval. Your range is exactly the same. It is this interval here. Okay, this interval here, from here to here. We're just going up and down because that's what our range would be, our y values. So your y here would be less than or equal to 3, okay, because that's this top point up here, and greater than or equal to the part down here, which is a -3. Okay, that's not the best writing. Let me go over that because that's kind of hard to see. Okay, so a -3, y, put a y there. If you put an x there, then it's not going to work. You got to have y because it's our ranges. Okay, so here's my y's and here's my x's. That's my domain and range. Okay, now I'm going to come back to the function piece of it. Let's just go ahead and get our domain and ranges. So I'm going to do a box around all of this. Okay. Again, this is my interval notation. You see that right there? So when I go to do my domain, it is going to be, okay, less than or equal to 7, greater than or equal to -2. Okay, I'll kind of cover that or undo that a little bit so you can see it again. I kind of got excessive with my coloring there. Okay, so -2 to 7. Oops. There we go. Okay, so that is my domain. Again, my range is my y values doing exactly the same thing, and it's the interval over here from, now I'm on my y values, so from 0 up to 12. Watch your scale, see, from 0 to 12. So if you'll think about our interval notation, our and notation when we were doing our absolute values, then those should make sense what we're doing. Okay, same thing, we're going to graph these, and maybe you don't want to do the whole thing. Maybe you just want to say, okay, my y or my x's go from here to here, and my y's go from here to there. Okay, you can even put you some endpoints on there. You see your two intervals. So when I go to do my x, less than or equal, greater than or equal, again, because I have a solid line, you don't see any open circles. So my x is going to go from over here to from a -16 to 16. Watch your scale. Okay, that's my domain. My range is going to go from -4 to 4. Okay? So domain and range, hopefully that makes sense. Think of it in terms of your interval notation for your absolute value. Okay, so I'm going to erase off again, and I'm going to go back to the original graph. Finding whether or not this is a function is actually pretty easy. Okay, and we have a name for it, and it's called the vertical line test. And again, please note that somewhere in your vocab. Vertical line test. Okay, which means if I draw a vertical line, it must only hit in one point. Okay, now what I mean by that is when I come in here and I draw a vertical line down through here, okay, I only hit in one point. That looks to be a function, but I have to do it all over my graph. Well, most of the time you're not going to have to do it all over because you knew that one over here is not going to hit. But where would be a good one to draw would be right here. Okay? Because it's very easy to see that it hits these 2 points. If I write these 2 points down, this would be 2, 2, and this would be 2, -1. And so do you see on that how my x repeats itself? Okay? Which means that this one is not a function. And a lot of times you can, okay, you can just look at it and see. Okay? So if I draw a vertical line anywhere on here, am I going to hit more than one spot? And the answer would be no. This one is a function. Okay? This one you should know without even drawing a vertical line. But yes, I can draw a whole bunch of vertical lines and hit, right? I could just keep going. I'm hitting and hitting. So this is definitely, circles are never functions. Not a function. Okay? Now, it's really interesting because when we're studying functions, all year we study functions on there. And the only type of function only graph that we study that is not a function are circles and ellipses. And so usually that's towards the end of the year because we study all the functions first and then we get the ones that are not functions. Okay? So hopefully that makes sense. Again, if you're doing your domain and range, draw a box around it. Look at it like an interval. Again, be sure you do x's and y's, x's and y's. Don't do just X's and X's or X's, Y's and Y's. And then again, do your vertical line test. Be sure you pause this and write your notes down for what a vertical line test is and your domain and ranges.